Hi, everyone. Hello. So, welcome to Operation Research 2, right? Can you hear my voice well? Can you hear well?
Yes.
How about you, Salim? Can you hear me well? Okay, so uh, I will give you introduction to optimization. Okay, you can follow this in Lentera. Can you see the slide? Okay, so last meeting we discussed about mathematical model, right? So today I hope we can discuss about optimization and then in touch of programming and knapsack. Okay, that's our agenda for today. Okay, so glad. So this is probably you have learned in OR1. Okay, so I want to make sure you remember all of this. Okay. So we have unconstrained and constant optimization. Okay. And we have standard optimization model. And then you need to be able to transform the objective function, for example, from maximizing into minimizing. Okay? And you also need to be able to transform the inequality into equality. So, and at the end of this lesson, we want to classify several optimization model and discuss some software. Okay, so first of all, why do we need to optimize? Right. So because we want to reduce the waste, yeah, and the cost. Okay. So by optimizing means you to remove the redundancy. So it can lead to higher profit and success in competitive fight. Okay. Number two, you can improve the efficiency, yeah, and also increase the productivity and the performance. That's why we optimize. So remember, optimization is the third level of science, right? You remember? My voice is not clear. Is it okay now? Can you hear me well?
Can.
Okay. Okay. So uh, last meeting we discussed about three level of science. You remember? So we have understanding phenomena, prediction, and optimization, right? So now, having said that, optimization is the third level, yeah, that we can control the things that we want. So the most important things that uh, you learn from operation research, yeah, is not to solve the problem because actually this problem solving can be done by computer software. Okay, so the most important aspect is actually to learn the OR, is the ability to transform the real problems, okay, in the work problems into optimization formula. Okay, once you can transform the actual real world problem into optimization formula, then you can put that into software. Yeah, for example, Excel solver, R, Minisync, Lingo, MATLAB, and so. Okay, so that means in learning any OR algorithm, okay, important to understand is what is the assumption behind it. what are the invariants, right? So what are the strength and weakness of its algorithm, right? And then the general idea on how it is done. Okay, so you will ask why this algorithm work, why this algorithm is created. Okay, that is the most important learning in OR. Now, first things, okay, this is called unconstrained optimization. So what you want to find this factor x, okay, in order to maximize or minimize certain objective function, and you have no constraint. So this is called unconstrained optimization. Okay, you want to find the input knowing the output that you want to maximize or minimize, okay, and you have no constraint. Okay. Okay. You have the function and the output you want to maximize or minimize, and you want to find the input. You remember, optimization is a inverse problem. You want to find the input knowing the output. So, unconstrained optimization is actually a special class. Special class of optimization that has no constraint. It has objective function. So, for example, this one. So find x and y, okay, that minimize this function. This is a quadratic function. Okay, then you will find the minimum at x and y at 1. Okay, the value is 0. So, do you know how to do this?
Make it
Anyone?
equal to 0.
What?
Make it equal to 0.
Make it equal to 0? No, you need to take the first derivative.
Oh,
You need to take the first derivative and then equate it to 0. Okay? So if you find unconstrained optimization, okay, what you need to do is to take the first derivative. So who can do the first derivative of this? Celine, can you do first derivative? Tiara? What is the first derivative? This is polynomial, so very easy to create the first derivative. What is the first derivative? F accent equal to? Oh, you are mute. Make it unmute. What kind of unmute? So the first derivative is 2 minus 2x, right? There. So the first derivative is 2, this one, and then this exponent here going down, so become minus 2x, and equate this to 0, then you get x equal 1, right? And then you put it in here, x equal 1, then you will get the maximum value, which is 2. Yeah. You remember this, right, in calculus? So, and you can also see the drawing. Yeah. So this is what happened. You get the maximum value here. Of course, to make it clear that this is maximum, not minimum, you take the second derivative. Yeah, you take the second derivative. Okay, so from here the second derivative is minus 2. Yeah, so minus 2, that means this is maximum. Yeah, if the second derivative is negative, that maximum. Okay. If the second derivative is positive, that's minimum. Yeah. So now let's go to general optimization. Okay. So in general optimization, again, you need to find X in order to maximize or minimize. Yeah. Either maximize or minimize. And you have the objective function. Okay. And then you have three types of constraint. So these are the three types, very general constraint. First, you have equality constraint. Okay. And then you have inequality constraint. So inequality means less than, equal, or larger than equal. Yeah? Equality means equal. And then you have boundary constraint. Its X is between certain value, within certain range, lower, upper. Okay. So this is very general optimization model, either maximize or minimize. Yeah? The constraint, again, you can have equality or inequality and boundary. So now, having that general, we want to create what is called standard. Okay. When we say standard, that means usually we want to maximize the objective function. Yeah. So when we say standard optimization model, you want to maximize, find the vector X in order to maximize, not minimize. Okay, the standard is to maximize. And then subject to constraint only less than or equal. Yeah? There is no larger than. So that means from this general optimization, you need to transform to the standard optimization model. Okay, so two things you need to transform, right? Number one is the minimization into maximum. Yeah. Second is the larger than into less than. Okay. So let's get the interpretation first. No? Optimization is always related to decision to allocate some resources. So the X is called decision variables. This represent the activities that use some resources. Okay, there are some number alternative way to use that resources. So then its activity will return some value to the objective function. Yeah? So the constraint here represent the limited quantity of the resources. Yeah? The one that you put constraint are always the decision variables. Okay. Now, if you want to convert into standard form, that means you need to convert the minimization into maximization. Yeah? So how to convert? Easy. Yeah? So maximization of fx is equal to minimization of minus fx. So in that case, if your problem is minimized, then you want to make it maximize, all you need to do is to put minus. Okay. Now the same thing here. If you have inequality that is larger than, okay, to make it smaller than, you just multiply by -1. Yeah? So any inequality with this GIX less than 0, that is equal to minus GIX. So you just multiply by -1, then you can transform the general optimization formula into standard form. Okay. So now from the inequality, now you can also transform inequality, which is less than or larger than, into equality constraint. Why? So that you have a better standard form, which is only equality, without inequality. So if you have inequality constraint Gx less than Bk, Gk less than So inequality is less than, then what you need to do, you add what is called slack variables. Yeah. So slack variable must be non-negative. So you add with slack variable. So here, yeah, gk is less than b. So if you add with k xk, then it will become equal. Yeah. On the left hand side, you add with xk, it will become equal. We don't know xk, but you will compute this later. Okay. Second, if you have inequality constraint which is larger than, then you want to transform this into equality constraint, then all you need to do is subtract, yeah, with the negative or surplus variable. Yeah. Again, this surplus variable must be non-negative. Yeah. So that's why this one is negative here, so that this one is non-negative. Is that clear? So I'll give you example. Okay. Let's convert this one. Okay. So 5x1 plus 6x2 less than 20 or less than. Okay. So what you need to do, you add slack variable. Yeah. So we introduce a new variable. So we call it x3 or x1. Okay. So what is the value of x1? S1 is 20 minus 5x1, yeah, minus 6x2, you know. So then you will have, this one is S1. So that will become 20. Yeah. So this S1 is called slack variable. Yeah? And this must be larger or equal to 0. Up to here, is that clear or not? You've done this in OR1, I guess, right? Okay. So again, in OR1, you have a linear programming problem, right? So this is the standard or general, probably. So you have maximization problem of a function with this linear function, a alpha I times xi sum. So this is a linear function. Subject to constraint, again, the constraint is equality. You see here, A is the matrix times X equal to B. Yeah, and each X must be larger than, must be positive, yeah, or 0. So this is the standard form of linear programming. Okay, so you want to find X, okay, in order to maximize this function subject to equality constraint. Yeah, so this is the standard form. Remember, in standard form, all constraints are expressed in equalities. Yeah, this include the slack variables and surplus variables. And then this one must be maximized, yeah, not minimized. Okay, so in general, okay, if you have a problem, okay, number one is to think how many objective functions. Okay. If you have only one objective, we call it single objective. If you have multiple objective, then you probably want to do a goal programming. Okay. Which objective is the most important? Okay. Number two, once you know the objective, check whether this is unconstrained or constrained. Okay. Then check also, okay, whether the variables, okay, the decision variables are continuous, integer, discrete, or mixed between continuous and integer. Okay. And then the last one, you check whether the function is actually linear or non-linear, whether they are convex or not, or whether they are differentiable or not. Yeah. So based on these, okay, you will know the classification of optimization, yeah, which algorithm that you will use. Okay. Most that we use is just single objective, constraint, okay, either continuous or integer or mixed probability, okay, and convex, okay, or differential. So this is usually what we learn in undergrad, right? But when you start to go to graduate studies, you will deal with nonlinear, you will deal with non-convex and non-differential. That's the thing that make it more difficult. Okay. So again, this is in terms of decision, the same thing. Yeah? Whether the variable is discrete, continuous, mixed, or whether they are actually deterministic or stochastic. So convex or not. These are the classification of the optimization. Yeah, based on that, then you will see what algorithm we should use. Okay. So if your algorithm is deterministic or stochastic. Stochastic means using random number. Okay, deterministic just using mathematics. Yeah? So linear programming is basically deterministic algorithm, including nonlinear programming. All the gradient-based algorithm are deterministic. Yeah? So you can also deal with stochastic, whether you are using heuristic or meta-heuristic. Okay? Meta-heuristic usually based on population or based on trajectory. Yeah. So these are classification of algorithms. So there are thousands of optimization algorithm out there. Okay. So this classification probably helpful when you deal with so many algorithms. Okay, up to here, is there any questions so far? This is just introduction. Dennis?
Not yet. Not yet.
Huh? Okay, so in optimization, you need to remember the meaning of local optimum and global optimum. Yeah? So example, we are doing here. Okay. So this point, this function, this is the curve. So this is called global maximum. Okay. Within this range, this is the highest, right? And within this range, this is the lowest. Okay. So in this case, this is the local minimum. Okay. This is called boundary value. This left and right. And this is called local maximum and local minimum. Okay. So if you use gradient method, for example, Newton method and so on, so you can say, for example, using Excel, usually it use gradient method, right? So what happens if the start from here, okay, it will trap to the local maximum or local minimum. Okay, so then you may not get the actual global maximum or the global minimum, depending on your starting point. So in any optimization algorithm, okay, most important is to, if you want to get the global optima, yeah, either maximum or minimum, then you probably need to restart, okay, the initial point, yeah, randomly, so that you may hit one of the global optimum. Okay? If you start only one initial point, then it may hit only the local optimum, yeah? Minimum or maximum, not the global one. Okay. So in terms of software, okay, if you use Excel, yeah, there is solver add-ins included in the Excel. So this is enough, right? But if you have only like 200 constraints, this is enough. No? Yeah, but for real project which you have probably 1,000 or 10 of thousands constraint, then you probably want to use this free software or more expensive software. Yeah. So these are very expensive software. Okay, Lingo, MATLAB, and so on. They can go up to a million of constraints. Okay. So The reason they are very expensive because very specific algorithm inside. Okay, so you can check on your own. These are the links that you can check. Okay, for the purpose of class, I think Excel is enough. If you want more detail, you can use Minisync, which is free, or you can use Python or Google Spreadsheet with Solver Advanced. Okay, but for the real project, you probably want to do much bigger than this. Okay, I mean for the business. So the number of variables, the number of constraints matter so much. Okay. So I've been talking about convex. Right? What is the meaning of convex? Mathematically speaking, okay. So if you have a set S in the real number of n dimension, okay, so then we call it convex when we can form this value. Yeah. So if you have a two variable x and y, which is in S, okay, then you can put the parameter t here between 0 and 1. Okay, so this one is t, and then this is 1 minus t, so that the total is 1. Okay, so this equation is called convex for two variables. Of course, if you have more than two variables, it's just a linear combination. Okay, in linear algebra, you remember linear combination. Okay. Linear combination so that the weight, the total weight, yeah, the sum of weight is equal to 1. That is the meaning of convex. Yeah. Geometrically, convex, yeah, in 1D, okay, is something like this. This is the convex function. Right? In 2D, convex means any 2 points can be put alike. Any 2 points. So this is convex. This is non-convex. Why? Because these 2 points can be put one line, but the line will have outside of this boundary, right? So this is non-convex because it's up. The line will pass through outside of this boundary. So convex means any 2 points here will always be inside this boundary. Is it clear? So there is another type of optimization. Yeah, this is called constraint satisfaction problem, or CSP. Yeah. So using Minisync, you can use this, but using Excel is very difficult. But very difficult. Yeah. So this is another type of optimization problem where the mathematical question, okay, is defined as the set of objects whose state must satisfy a number of constraints or limitations. Okay. So you have a set of variables in a certain domain, and usually integer, and then you have a set of constraints related to those variables, and then the goal, yeah, the goal is not equal or maximize, but to satisfy. Okay? The goal is to satisfy the constraint. To find the value to satisfy the constraint. So I give you example. So say you have x, y, and z. Okay. X, y, and z are one-digit integer 2 to 9. Okay, each having different values, so must be unique. Yeah, x must not be the same as y, must not be the same as z. So one-digit integer from 2 to 9, not 1, not 0. So question is, what are the value of each of this letter? Okay, y plus y equal x, x plus x equals z. This is optimization problem. Yeah? So suppose if you set x equal 2, y equal 9, so 2, 9, 2, 9. Okay. So it's not 2 multiplied by 9, yeah, but 29. So 29 plus 29 is how much? 58, yeah, 58. So but this is not correct because x must be 2, not 8, right? So then you need to find what is x and what is y and what is z. Can you do this by inspection? Dave? How do you do? So 2 times y, you can calculate that y plus y equal x, right? And then x plus x equals z. But there is a possible y plus y equal x plus the carry. Yeah, you can have carry. Okay, so y plus y equal x. So what's the conclusion? Any number, any digit, yeah, if you add and then equal x, x must be yes, Dave. Huh?
Sir, yang can
Tiara?
we put 4 for x and 2 for y?
Yes, you can. Yeah. So that's correct. Yeah. So if you have 2y equal x, right? Then x must be even number, right? And then 2x equals z, then again z must be even number, right? So then you said the digits are eliminated from 2 to 9. So you can try, yeah, you can try y equal 2, x equal 4, then z of course become 8. Yeah? So this is one of the solution of this puzzle. Yeah. So okay, can you do this? Okay, let's try again. So its letter is 1 digit, integer 0, 1, 2, 3 until 9. It's having different values. Okay. Send more money. So what are the values of its letter? So this is called CSP, yeah? Constraint satisfaction problem. Okay, so what you need to do, you put, yeah, you put into algebra, yeah, you put 1 by 1 into algebra. So you have this one d plus e, right? You have d plus e equal y, correct? Yeah, and then but this one must be carry, right? There is a carry. The carry mean 10 times C1. Yeah, this is C1 mean carry 1. And then now C1 plus N plus R equal E, correct? Yeah. So then you have carry 2. Yeah. You have carry 2. And then E plus O plus carry 2 become N. Yeah, plus carry 3. 10 times carry 3. And then S plus M plus carry 3 become O plus carry 4, yeah. And then that carry 4 must be N. Oh, now we have this 5 equation, yeah, carry is the summation, yeah. So what you will do, oh, this is linear algebra, isn't it? Huh? Can you put this? Oh, what you will do, you will put this into matrix, yeah? Okay, you put this into matrix like this, right? And then what you will do, so you just put in all this into matrix like this, and then on the right side is equal to 0, then you will have the result. Yeah? Any question? You can do it. Interesting, huh? So this is one of the application of what is called constraint satisfaction problem. Yeah. So this is part of optimization. Yeah. But the goal is not to maximize, not to minimize, but to satisfy. Yeah. So is it clear or not? Is there any question? Clear or not? You can do it, right? You know how to solve this, no? This is just a Gaussian elimination. Because you took linear algebra, so you know how to solve it. You can use RREF, no problem. You remember? Okay, so once you do that, you will have the solution. Yeah, this is the solution that you have. How about this one? The same, yeah. So you can create your own in order to make yeah, baseball equal games. The same, yeah. Gerald plus Donald equal Robert. I have a lot of challenge here. Okay, so one of these probably will go to the quiz or assignment, or no, quiz or the exam, yeah. Okay. Okay, so is there any question? Okay, give me feedback. What did you learn?
Basically about optimization, sir.
Okay, what
We
is
can like simplify. Yes, like the
simplify what?
how to say yeah, like yeah, we can like not much ya, but itu loh yang kayak ini simplify. I don't know what to say. Indonesia, you know what I mean. Like simplify.
Simplify what? Okay. I cannot hear you. Can you unmute?
Yeah. Actually, we confuse how to say it, but like
But you know.
we know like the example like if if y and y will become x and x will become c, but like we don't know how to say.
Oh, okay. In that case, can I give you assignment how to compute this? One of them. Individual assignment, is it okay?
Right now,
Or you want to practice now? You want to
yeah,
practice now?
practice now. Practice.
Now? Okay.
Yes.
Okay. So you want practice with The answer or without the answer? Okay,
With the
so
answer
this one,
or without,
this one,
with or without the answer.
without the answer. Okay, so this one is, who will do this? Baseball game. One, I have one, two, three. Oh, okay, four is this one. This one have answer. So one, send more money, have answer. Baseball game, no answer. Gerald, Donald, and attraction intention. So each one of you choose one and then solve it.
You choose for us, Master. We cannot choose.
Huh?
You, the one who give us the question, Master. We cannot
Okay,
choose.
I will give you. So, okay, Dave, can you solve this? Attraction plus intention equal to regeneration. Dave, write down. Anyway, you have the slide, right? Okay, so this is Dave, okay? This one, Gerald and Donald, who? Gerald and Donald equal Robert. Who will do this? One of the three girls. Okay, Tiara, do this, yeah? Gerald and Donald equal Robert. And this one, Kalista, base plus ball equal games. And Celine, sand plus more equal money. Okay, you can do it in Excel, you can do it in Notepad, whatever. Okay, I will wait. This is the address, so you can check. Okay? Once you finish, you share your screen, okay? So there's a book. I don't know if you can see this book. This is the book about the CSP, yeah, the principle of constraint programming. Can you see? So one of the content of this book, yeah, is about this arithmetic. Of course, it goes beyond that. By Christoph. Yeah, study of it. You can also do this in Minisync. Kalista, you want to show your work? Or Dave? Okay. Okay, so
Sir,
yes.
the answer will be only like 1, or is it possible if we change the number? So like the answer more than 1.
Oh, you mean is it unique or not unique? It's not unique. The answer can be more than 1.
How if like
So
can we put like 0 in front? Like I mean like when
that
I
is
put
a
m
good
m
question.
equal to 0.
Yes, so it's possible. So uh, I will show you the website. Can you see this? This is send more money, right? And we put the expression, right? So this one, yeah. So you can have like this. If you put 1 in here, you can have, or if you put m is equal 0, so you have actually 25 possible solution, yeah. If m is equal 1 or m equals 0, so there are many solutions. If m is allowed to 0, the solution is not unique. Okay, these are all possible solutions. But if m is equal to 1, then there is only one unique among all of this. Yeah. Right. There are so many non-unique solution if m is equal to 0. So this code I make using MATLAB. You can also do in Python if you want. Yeah, you practically you do using discrete math. You do a permutation of all the digit 1 to 9. Okay, and then you evaluate this expression. Okay, and then you report the unique value. So if you do it using linear algebra, it's also possible. A while ago, I show you, right? So the same thing with the baseball equal games, right? So we can use the same function, okay? And these are the 3 possible solution. The answer is not unique, yeah? Again, these are the 3 possible solution. Okay. And Gerald equal Gerald plus Donald equal Robert. Okay. In this case, you have only one unique solution. While for the attraction plus intention equal regeneration. So in this case, you have the solution is unique. It's a very long solution. So the key here is to generate all the permutation. Okay. First, you need to create the expression. Okay, first expression, second expression, and then the sum. Okay, and then you put that, and then you generate all the permutation. So this is what is called a constraint satisfaction problem, so, or constraint programming. You want to show your work, Celine? Probably.
Actually, I do it on paper.
All of us.
In
Yeah, all of
paper?
us, me, Kalisa, and Tiara, iya.
Okay. Okay, so I will put that in the assignment in Lentera. You can submit the one that you think. Is that okay? Yeah, okay. Thank you. So is there any question related to this first part? Introduction to optimization. Yes? No question at all? Wow, super. So you already learn about linear programming, right? So let's discuss about the what is called integer optimization. Now, this is similar to linear programming, but the values are integers. Okay, so this is what we will discuss. Or what is the meaning of integrality condition? Yeah? Why we need integer programming? Yeah, and then what happened if we want to solve general integer variables and then a binary variables and then mixed integer optimization. Yeah. So some problems in nature, okay, are naturally discrete or integer, right? So they are not real number, it is continuous, and not fraction, not rational number either. So for example, the problem of scheduling optimal number of worker in each shifting time. So the integer variables here is number of workers. So in that case, of course, you don't put half worker or three-quarter worker, isn't it? So by nature, it is discrete. Yeah? The same thing. For example, the problem of purchase optimal number of airplanes by its type. So the number of airplanes is discrete. Yeah? So if you want to select which project alternative, so for decision making, okay, so then the decision is either yes or no. So it is binary decision. So by nature, it is discrete or integer. So there are some problems that actually discrete in nature. So my question to you, each of you, can you give me several examples of problems and the variables that are discrete or integer in nature? Each of you. Give me example, okay, of variables, the problem and the discrete variables. Dave. You're still mute.
Hmm.
Give me example of any problem that the variables are discrete or integer. The choice are integer. or the choice are discrete. Really? You still have difficulty in this? Okay, so how about Celine, Tiara, Kalista? Give me example of problems when their variables are discrete. Anyone?
Pemilu. Iya.
What?
Voting or pemilu polling, like
Oh,
pemilu.
voting, yeah. So discrete, right? Say 1, 2, 3, that's correct. So what else?
The result of a rolled die,
Road die? What's that?
like dice.
Dice. Okay, the roll of dice. Okay. What else? Two more. Come on.
How about inventory, sir?
Inventory, is it discrete?
Yeah, kind of like the number of the stock,
The number of the
Number.
stock can be discrete, yeah?
number of pages.
Yes. The number of pages can be discrete, yeah? Okay. So,
Look.
I want you to know, okay, probably you know this already, but I want to discuss with you about measurement of scale, just to remind you again. Okay, so here. Can you see my slide, measurement of scale? So data, yeah, data can be classified into 4 types, yeah. So let's divide into 2, yeah. If you have data, any data can be classified or categorized, okay, by the type of attribute. Sometimes we call it measurement of scale. So we have a quantitative and qualitative data type, okay. When you said qualitative, that either nominal or ordinal. Quantitative mean either interval or ratio. Okay. Do you know this? What is nominal, ordinal? Anyone can say something?
Ordinal is more about like rankings.
Okay. And nominal?
Nominal, yeah. The amount, total.
No.
Some kind of like
Total is ratio. Okay. In that case, I really need to explain this. Okay. So there are 2 types. Okay. One is called qualitative and the second one is called quantitative. Okay. So qualitative consists of 2, nominal and ordinal. Quantitative consists of 2, interval and ratio. Okay. So qualitative data, okay, is the data that can be placed into distinct category. Yeah. Sometimes can be arrayed into meaningful order. Okay. But there is no arithmetic operation can be applied to them. For example, okay, blood type of the person is A, B, AB, and O, yeah, or 0. Okay. Assignment evaluation can be fail, pass, good, or excellent. Yeah. So these are qualitative data. Now, quantitative data are numeric. in nature. Okay, so qualitative is just distinct categories. So if quantitative is numeric in nature, they can be run, can have meaningful arithmetic operation. So this can be quantitative, can be discrete or continuous. Okay, so discrete data assume value that can be counted. So, for example, zip code. Okay, yeah. So the count itself are discrete, right? The total are discrete. Okay, so the word in the collection of documents, a while ago you said the total. Okay, those are discrete data. Okay, the number of family in a the number of children in a family are discrete data. Okay, they can only be finite, okay, or countable infinite. Yeah, so we often represent the discrete data as integer variables. Sometimes we also have what is called binary attributes. They are also discrete in nature. So in contrast, we have what is called continuous data. Okay, continuous data assume all values in the numbers line. Okay, so they are uncountable. The continuous data is a real or real number or floating points. Okay, they are uncountable. Okay, for example, temperature, yeah, height, weight, and so on. So these are continuous data. So next, we have what is called four measurement of scale: nominal, ordinal, interval, and ratio. These are the order. Okay, the highest type is ratio. A little bit lower, you get interval. Lower again, you get ordinal. The lowest is nominal. Okay, so let's discuss one by one so that you will know. Okay, nominal data is called category. Okay, so it just exists of the choice without the order. For example, gender, okay, male and female are nominal data. The color, okay, are nominal data. Zip code is actually nominal data. The name of kecamatan, the name of voting candidate, okay, they are 1, 2, 3. You can assign 3 to 1. That doesn't matter. Okay. Similarly with the gender here, male 1, female 2, or you can put female 1, male 2. It doesn't really matter. It's just assignment. The number itself does not represent anything but assignment. Okay, so the second type of qualitative data is called ordinal. It has sequence, it has order. For example, from hot, hotter until hottest. So there is an order here. Okay, so nominal data, yeah, or nominal level of measurement scale classified into mutually exclusive, non-overlapping categories. Okay, there is no meaningful order or ranking can be imposed on the data. Okay, I give you example. For example, the fruit I like is either apple, banana, orange. I can assign any numbers, 1, 2, 3, or I can assign orange is -1, 0, and +1. So the actual number does not matter because this number just symbol to represent that name. Is that clear? So when you have the symbol represented into number, number 1 is Anish, number 2 is Prabowo, number 3 is Ganjar. So these are just nominal variables. Yeah. So the actual number does not really matter because the number is just symbol, no meaningful value. Okay. So another example, gender is 1 equal male, 2 female. You can change the number. Yeah? Female is 5, male is 225. That's fine. Okay, so they are equally correct. Okay, both are valid as long as you have consistent definition. So the numbering itself does not really matter because the number is just assignment, just symbol. Is it clear? Okay. Now, go to the next level, higher, a little bit higher. This is called ordinal scale. Ordinal scale, you have categories the same as nominal, but you can have rank. There is an order here. Okay, you have rank, but you cannot calculate by arithmetic. You cannot minus, you cannot plus, you cannot multiply, you cannot divide. Okay, anything that you have number that you cannot add, okay, minus, okay, multiply, divide, that means ordinal data. Is that clear or not? Okay, so I give you example. Okay, there are many example of ordinal variables. Yeah, one is comparison index. For example, I put -2, I strongly disagree, -1, I disagree, 0 is indifference, 1 is agree, 2 is strongly agree. So this number have order, right? This number have order. Okay, so from -2 meaning strongly disagree until agreement. The same thing if you have rating. Yeah, 1 means very dissatisfied, 100 means very satisfied. So this number have order. It's not just nominal, which have no order, not just assignment. These have order. Okay. The same with if you say rank of priority is 1 is the best. So in the rank, usually the higher value will have lower importance. Okay. Another way to do ordinal variables is using ordering, yeah, or the sequence of label based on rank. So this is an example. So my preference of fruits vector is grape, mangoes, banana, apple, and orange. So in this case, the ordering is based on this vector, isn't it? So mangoes is 1. Okay, so this is based on the rank given, yeah. The grape is number 1, so I put 5 here, and then mangoes. Oh no. Wait, this is the preference of vector. Okay, the rank is here. The rank is given down here. 5, 1, 3, 4, 2. So I just put the rank here. So this is based on the preference vector. So my ordering vector now become mangoes number 1, orange number 2, right? Banana number 3, and then apple number 4, and then grapes number 5. Yeah. So this is ordering vector with this sequence based on the rank. Is it clear or not? Can you see the difference between rank and ordering? So next you have quantitative data. Okay, in quantitative data we have 2 types. Okay, one is called interval type. The second one is called ratio type. The highest is ratio type. Okay, in interval type you can add and minus, but you cannot divide. Okay, you cannot multiply, you cannot divide. In ratio type you have 0. In interval you don't have 0. Okay, so temperature is an example of interval. Okay, so interval data measure the scale of the rank data. The difference between the unit measure can be calculated by arithmetic, but you have no 0. Yeah, the meaning of 0 here is mean null, nothing. Okay, that doesn't exist in interval data. Okay, example of interval data is Fahrenheit temperature. Yeah, it has meaningful difference between 1 degree between each unit, but 0 degree Fahrenheit does not mean there is no heat, right? So 74 degree is just 2 degree higher than 72. That means you can minus. Okay, so there is what? There is a rank, there is ordering. You can do subtraction, you can add also, but there is no 0. Okay. The last but not least, but this is actually the highest, yeah, is the ratio level of measurement of scale. Okay. This possesses all the characteristic of interval measurement, and there is exists 0, so that 0 mean nil or nothing. Okay. So consequently, true ratio exists between different unit measure. So you have unit of measurement. So I give you here, in here on the left side, you have the actual length of this bar on the vertical axis. Can you see? Yeah. So you have A, B, C, D, E. Yeah, these are the actual length. Okay. But when you put it into ordinal measure, you will just put 1, 2, 3, 4, 5. Yeah, there is a ordinal scale here, which the length does not represent the actual length of this bar. So what's the meaning of this? The meaning is when you have the real value, the ratio type, okay? For example, you measure your weight, okay, in kilogram, right? Or your height in centimeter, for example. So that is ratio type, okay? So then you put that into interval. How do you put interval? Or every 10 centimeter, you will put the value of 1, 2, 3, 4, 5, and so on. Okay. So 1 meaning between 1 to 10, 2 mean from between 20 to 30, yeah? 3 mean between 20 to 30, and so on. Yeah? So you can also make it lower again by making it into ordinal measure. Yeah? Again, 1, 2, 3, 4, 5. Okay. And you can put down again into nominal, axis or not axis, binary. So from ratio type, you can put it into interval, you can put it into ordinal, you can put it into nominal, but every time you put lower measurement scale, okay, you lost information. You see here, this is an example. The length itself is actually lost. Okay. When you put down from the highest measurement scale ratio type into interval or down into a ordinal scale, okay, you lost information. Okay, so the lost information you cannot recover. Okay. For example, in the questionnaire survey, okay, you do questionnaire survey, instead of asking how much is your income, you are asking directly, you put the range of the income. So in that case, you only get either interval or ordinal scale. So you will not know the actual income, which is in ratio scale. Do you got it? Okay. That's why my suggestion, if you do questionnaire survey, go to the highest level, which is ratio type. Okay. Don't directly go to the ordinal scale. Why? Because from the ratio type, you can easily manipulate using Excel or something to go down to lower level. Okay. But you cannot go up to the highest level with this ratio scale. Is it clear or not? Okay. So these are example of attribute. Okay. Nominal example is ID number. Your ID number is nominal. Your eye color, your zip code are nominal. This is just simple assignment, okay, on any numbers. Okay. The number itself does not mean anything aside from the assignment. Okay. Ordinal, you have the grade, you have ranking, yeah, the taste of potato chip, for example, 1 to 10. The height in tall, medium, short, yeah, these are ordinal scale. You have order, okay, you cannot minus, you cannot, for example, tall minus medium, you have no meaning, right? Even if you put tall is 3, medium is 2, short is 1, so tall minus medium is 3 minus 2 is 1. Tall minus medium not become short, isn't it? So there is no meaning on the arithmetic of the ordinal scale. Okay. But in interval, yes, you can do arithmetic. Yeah. So date, for example, there is no 0, right, in the calendar. The same with the clock. Yeah? There is no 0. So because they are interval. Okay. So the ratio type, anything with units, yeah, Kelvin, temperature in Kelvin, yeah, length, the time, the count itself, the frequency are ratio. Okay, now each of you give me example of nominal, give me ordinal, give me interval, and give me ratio. Dave, start with you.
Example of nominal is like hair color.
Hair color, okay. Ordinal.
Mm, the grades of
Yeah,
students.
I already put here grades, so
Oh,
put
yeah.
something else.
Income of employees.
Hmm?
Is that income of employees?
Income of employees in what? Depending on the
In
scale. If you said low income, medium income, high income, yes, that's ordinal. But if you put income of employee, income of rupiah, that is ratio.
yeah,
If you put the income of employees in term of between range, nah? Between 0 to 1 million, between 1 million to 2 million, between 2 million to 3 million, that is interval because you have the same range. Okay. If you put the income of employee different range, so 1 to 5 million and then 5 to 50 million, that is not the same range, that become ordinal. Is it clear?
it's clear.
Any ratio you can put down, yeah, to interval, to ordinal, to nominal. Okay. Give me another example of ratio type, Dave. Ratio type, come on.
Height of a person.
Hmm?
Height.
Your
Height.
height. Okay, your height is a ratio type. That's correct. Okay, Celine, give example. Nominal, ordinal, interval, or ratio. This one is difficult to get the interval.
Nominal, maybe
Nominal, easy.
nationalities.
Nationalities, very good. Ordinal,
Education.
education, very good.
Yeah.
Yes. So ratio or interval. This is or. Both are quantitative, so you can select one.
Ratio.
Ratio type. Oh, ratio is actually easy. Anything with units. Anything with unit of measurement.
How about income?
Income, Dave already said.
Oh, okay.
Uh,
Wait.
You learn physics, right? You learn physics. How many variables
Yeah.
in physics? So many. So you just select one of them.
Wait.
In physics, what are the variables in
Acceleration.
physics?
Acceleration.
Eh?
Yeah.
You forgot about physics. Eka will angry to you.
Yeah. Acceleration.
Acceleration. Okay. Acceleration is ratio type. Okay. What is the unit of acceleration? What is the unit of acceleration?
M per S.
What?
Wait.
M per S is speed.
Penting nggak sih? Iya, M per S. M per S. Iya, benar. Iya. Itu M per S square.
M per S square.
Meter per second square. Per
Yeah,
second
okay.
square.
Okay, so Kalista, give me an example of nominal, ordinal, interval, or ratio.
Marital status.
Marital status is
Ya,
Nominal.
nominal.
nominal, okay. Married or not married, okay. Single.
Hmm.
And then ordinal, give me an example of ordinal.
Does birthdays count?
Birthdays count, yeah. Ordinal.
And
Interval or
what
ratio?
else?
Interval or ratio.
Or.
Yeah.
Or. Any quantitative
Tadi kan
variable.
sudah disebutin nih belum? H. Udah ada.
H is is there
Ratio.
any 0 H? Yes. Okay, so ratio. Okay, the unit is year, right? Okay, good. Tiara,
For which one, sir?
nominal, ordinal, interval, or ratio.
Berarti aku nationalities, Kalista.
You finish on nationalities. You choose something else. The
Marital
last one is more
status.
difficult.
Jadi
Come on.
something.
Hey,
Nominal.
nominal. Anything that categorical.
Hair color.
It's already did by Dave.
Like the type of like maybe car or phone.
The type of car, yeah, the car brand. That is nominal. Very good. Ordinal.
Oh, yes. Satisfaction rating.
Satisfaction rating. Very good. Interval or ratio.
Yeah.
Anything with units.
Like what's like money unit?
That is already done. So, you know,
Oh,
a lot of variables in physics. You just give example of that.
yeah. Unemployment gravity.
Unemployment rate. Okay, unemployment rate is ratio.
Ratio.
Yeah, okay. So energy, I'm casting. Energy, nominal, ordinal, interval, or ratio. Energy. How do you measure energy? What is the unit of energy?
Joule, so it's ratio.
Is ratio. Very good. Now, faith. How do you measure faith? Is it nominal, ordinal, interval, or ratio? Your faith to God. Come on. Faith is measured by ordinal scale, okay? So anything you cannot measure by quantitative value, you can always measure by ordinal scale. Okay. Your love. Oh, you love your boyfriend, you love your girlfriend. So what is the value? What type? Nominal, ordinal, interval, ratio. Love. Love between 1 to 10.
Interval. Loh, ordinal.
Interval nggak sih?
No,
Ordinal rank.
Wait, from 1 to 10 ordinal. Nah, makanya kalau from 1 to 10 gitu.
ordinal, yeah. The same faith 1 to 10 is ordinal, okay? So they are just ranking. Similar to satisfaction. Is that okay? So important here is the nominal level is the lowest, right? So it is the least powerful in that it provides the least information about the data. Ordinal is higher, followed by interval, then the ratio is the highest. Now, this is important. Any data conversion from the higher level measurement scale to the lower information to the lower level of measurement scale will lose information. Okay, so to distinguish between these four, okay, you check here. These are the simplified version. Whether you have distinct enough or not. Okay, distinct mean equal or not equal. Whether you have order or not. Whether you can have addition, subtraction or not. Whether you can have multiplication or division or not. Okay, so if you have nominal attribute, you will have distinctness. If you have ordinal attribute, you have distinctness and order. Okay, if you have interval attribute, you have distinctness, order, and addition. That includes subtraction. And if you have ratio attribute, you have all these four properties. Is it clear? Now, this is what is very, very important. Okay, so you have nominal, ordinal, interval, and ratio. These are the example and description like a while ago. Look at the last column there. The last column, yeah, the operation. Can you see? So if you have nominal data, you can only do mode. Yeah, you can do entropy, you can do a correlation, contingency, and chi-square test. If you have ordinal, you can do median. Of course, you can do mode. Okay, remember median is ordinal is higher than nominal. That means everything that nominal do, ordinal can also do. Okay, if your data is ordinal, you can do mode, you can do median, but you cannot do mean. You cannot do standard deviation in ordinal data. You cannot do standard deviation in nominal data. Clear or not? Okay. So you can do percentile, ranking, rank correlation. Okay? You can do run test, sign test. Okay? These are the statistics. Okay. Now, if your data is interval, you can do mean, standard deviation, Pearson correlation, t-test, f-test, no problem. So all of these are quantitative, right? But if you do ratio attribute type, you can do more than that. Yeah, you can do geometric mean, harmonic mean, which interval data you cannot do. Okay, so again, the highest is ratio. That means ratio can do median, can do more. But the other way is not correct. So if you have nominal data, you cannot do median, you cannot do mean, you cannot do geometric mean. Clear? Is it important or not? So
Yes, sir.
yes, question?
Oh, no, no, no.
Now, if you want to do transformation, okay, a while ago, in crypt arithmetic a while ago, we can on because they are nominal actually, right? So we can do any permutation only. Yeah. In ordinal data, you can do a function that preserving any value. Okay, for example, 1, 2, 3, you can make it into 0.5, 1, and 10, no problem. There is no, as long as monotonic function, there is no problem with that. Okay. When you have an interval, you can do linear transformation. Okay. When you do ratio, you can do any transformation, basically. Yeah. So because ratio is the highest, right? So you can do any transformation. But be careful, if you have only ordinal data, you can only do monotonic function. Like logarithm, you can do, yeah, linear function you can do, but you cannot do using nonlinear. Okay. So these are the algorithms, very simple algorithm to test whether they are nominal, ordinal, interval, or ratio. Yeah, you check. Yeah, is there any ranking? No. Can you do arithmetic operation? No. Is that arithmetic 0? No. Then it is nominal. Huh? So check again. Is there any ranking? Yes. Okay. No, no. Then it is ordinal. Yeah. So if you can do arithmetic ranking, if you can do ranking and arithmetic operation, yeah, this is interval. Yeah, but no arithmetic 0. So if you can do everything, that is ratio. Is that clear or not? So as the summary, okay, you have two types, right? Yeah, qualitative or quantitative. Yeah, qualitative can be divided into nominal and ordinal. Yeah, quantitative is either interval or ratio. Yeah, interval can be discrete or continuous. The same thing with ratio can be discrete or continuous. So up to here, is there any question? Is it clear or not? No question. So give me feedback. If you don't have any question, you can give me feedback. What did you learn? Dave.
Yeah, learn about the different data types, qualitative and quantitative, and which one that can be standard deviation.
Now the deviation is only for
Wait, I
the
forgot.
deviation is only for quantitative, okay?
Yes.
Oh. So if your data is nominal, you cannot do standard deviation. You cannot even do median. Okay, ordinal data you can do median. Clear, yeah? Good. So let me stop this. And let's go back to integer programming.
Sir, can we have a break first? Before
Oh,
continuing?
sure. Sure. Okay. Until what time? Okay, welcome back. So, I posted in Lentera your assignment today. The Greek arithmetic. So you can do all four example a while ago in either Python or in algebra. So, and record it, okay? And list also all the feasible solution. Show you that. Can you see? Okay. So let us come back. Okay, let us come back to our discussion in integer programming. So with this introduction a while ago, so I hope you can give several problems and variables that are discrete or integer in nature. So Dave, give example of problems and the variables in discrete. Stay there. Oh, Celine.
Yes, sir.
Oh, give several example of problems and their variable that are discrete or integer in nature.
Oh, polling. Oh
Polling.
yeah, voting. Yeah.
Voting.
Oh yes.
What else? Tiara.
Queuing problems.
Okay, queuing is probably discrete also. The number of people, right? And who's that? Kalista.
Kalista still on the toilet, sir.
Okay, so Dave, give me several example of problems and variables that are discrete or integer in nature. Dave, any example, Dave?
Mm, discrete or integers in nature.
Yeah. What? We just discussed a lot, huh? Nominal, and that means any nominal, ordinal, and quantitative, either interval or ratio, which is discrete. Yeah. Remember, quantitative can be discrete or continuous. Right? If not, you just put binary.
The number of people that passed an exam, number of students that passed an exam.
Okay, the number of people that pass an exam. Okay. So let's go to what is called integer programming, yeah, IP. Yeah. IP here represent integer programming. Yeah. What is IP? IP or integer programming is a linear programming, yeah, LP, where some or all of the variables are non-negative integers. Okay, so when all variables are integer, we call it pure IP. And some of the variables are integer, we call it mixed IP. Yeah. So when you have pure IP, okay, if all variables must be equal to 0 or 1, we call it pure binary. Okay, or 0, 1 IP. Okay. If some, not all, yes, if some of our variables are integer, it can be binary also. This is called mixed IP. Is it clear? So other name is also called integer linear programming, ILP. Okay. So that means integer programming is a linear programming, yeah, where the sum or all variables are integer, yeah, non-negative integer. So this is an example. Okay. Hey, what is this? This is pure IP. Why? Why this is pure IP? Oh, Tiara, why this is a pure integer programming? Anyone can answer? Dave? Why this is pure integer programming? Anyone knows? What make it integer programming? Have you seen this kind of mathematical equation? Right. You learned this in OR1, right? Okay, so this is maximizing something, yeah, the objective function which is linear, and then subject to this constraint. Okay, what make it pure IP is this one. X1, X2 is integer. So this is the one that make it pure IP. Why? Because both of them are integer. You see, X1 and X2 are integer. So this become pure IP. Yeah, pure integer programming because all are integer. Is it clear or not? When all, yeah, all variable are integer, this is called pure IP. Clear? Okay, next. This is called mixed IP. You see why this is called mixed IP? Yeah, because X1 is integer, but X2 is not. Okay, X2 is not required to be integer. So this is called mixed IP. Is it clear or not? Yeah, mixed IP, come back again here. If some of the variables are integer, but not all, this is called mixed IP. Clear? Huh? So how about this one? 0 and 1 IP. Huh? So what's make it different? This one, the last one. Huh? X1 and X2 are integer, yeah, either 0 or 1. So this one become 0 and 1 IP. Then you will ask, Hey, come on, only the limitation of the values, that is the one that make it integer programming, yeah. Okay, either they are integer or binary, then become IP, yeah, integer programming. So let's learn what is called LP relaxation, yeah, linear programming relaxation. So one basic approach of solving integer programming is to relax the integer constraint, right? So if you relax the integer constraint of the integer programming, it will become just normal linear programming. Okay, how to do that? You just ignore the integrality condition and then you solve it as if, okay, they were standard linear programming. So I give you example. So this is example. Okay, this is IP. This is integer programming. How do you know this is IP? You see here, this one, x1, x2 are integer, right? Can you see? How about on the right side here? The right side is exactly the same, okay, except the last line here. Okay, x1 and x2 is not necessarily integer. So when you have this problem, IP, okay, and then you relax the last constraint, okay, to be integer, then this is called LP relaxation, yeah, linear programming relaxation. So what's the difference? The difference is only this one, yeah, only the last part here. Okay, so if you do LP relaxation, yeah, this is the example of a while ago, right? If you do LP relaxation, you will have this as your solution, right? So these are the boundary of feasible solution, okay? And then when you say feasible integer solution, so you just get all the discrete, yeah, the integer values here. Okay, these are the points of a feasible integer solution. Then you get the highest value in terms of the objective function. Okay, so by having LP relaxation, you will not get the actual solution, but you will get the boundary. Yeah, you will get the boundary, and then from that boundary, you can list all the possible feasible integer solution, and then you get the highest or the if you want to maximize. Yeah? So the relationship between optimal IP and optimal LP relaxation, yeah, the objective function value to be of the optimal IP can never be better than the objective function value of the optimal LP. So the IP must be smaller, yeah, you see, unless they are touched in this boundary, right? Then it is the same as LP relaxation. Yeah? So IP is always not better than LP. So for maximization problem, you will see that the upper bound matter. For the minimization problem, the lower bound matter. Yeah. So that means if we found an optimal IP, okay, then the objective value must be lower than the LP relaxation. Yeah. So this is an implication. This is not by implication. Okay. So we can round off. Okay. So if you do a round off, the bounding optimality is an implication, so not equivalent. So in that case, even if you round off the value, the result, you will not get the actual optimal value. So the question is, can we just round off the LP relaxation to get the integer solution? The answer is no. Why? Yeah. Because when you truncate, yeah, round up or down, it may go to the invisible region. Yeah. So even if within the feasible region, there is no guarantee that it is the optimal integer solution. Yeah? So you cannot just get the LP relaxation and then round off the solution. That is not true. Okay. So this is an example. Okay. If you do this LP relaxation, okay, and then you round off, it will go out of the visible region if you round down. Yeah. So the actual solution is this one. Yeah. 2, 1. But if you put it using LP relaxation, this is close to this one. So you will say, oh, this one probably the solution. 1, 1 is not. Yeah. Clear, yeah? So you also, if you round up here, you will get 3, 3, 1 here is also outside the visible solution, yeah? So then the question is, why? Why we need to have IP separate from linear programming? Because integer programming is algorithmically much more difficult to solve than linear programming. Why? Because we have what is called combinatorial explosion. Okay, there are some problem with large variable which is unsolvable. So this is called NP hard or NP complete. Yeah. So you go to this Wikipedia. Okay, you go to this Wikipedia. Okay, some problem can be solved using polynomial time. P is polynomial time. Okay, some problem cannot be solved using polynomial time. That means you need to do NP, that is not polynomial time. So there are some problem that is very hard to solve. So we have also what is called NP complete. It is the intersection between NP hard and the non-polynomial NP. Okay. So this represent the time analysis of algorithm. You remember? I showed this last time during programming lessons. Okay, there are some problem, okay, with this non-polynomial that if the problem size is large enough, okay, you need millennium to solve this kind of hard problem. So there are some problem that you cannot solve using computer. Okay, so depending on the big O notation that you have. Okay, polynomial, that's mean n square and third of square root. So these are polynomial. This is already power, and this is what is this? Factorial, yeah. So factorial, even n is 25 only, it take millennium to solve, yeah. So cannot be solved. Okay. So that's why you need separate technique, yeah. So we call it IP because they have a separate technique. So these are a prominent algorithm in integer programming. Yeah, you use cutting plane or LP relaxation. You have a branch and bound or 0, 1 implicit enumeration. The most famous one is interior point. Okay, but for the sake of this class, so I don't discuss any of this. Okay, but if you want, I can give you the books or you can search on your own over the internet. Yeah? As long as you know the name, it's easy. Yeah, you can search more detail if you are interested to go more detail about this. Okay, so when you use software, for example, using Excel, okay, there is not so much different. Yeah? All you need to do is just to set the constraint to be integer or binary constraint. Yeah, so you go to solver, right? And then you set the objective value, okay? And then if you use binary constraint, so you just put this bin, or you can choose integer. And the constraint can be integer or binary. Is this clear? So now, can you solve this? So let's practice, okay? I want you to do this practice. 1, 2, 3, 4. Oh, okay, exactly. So who will do this? Let's practice number 1. This is practice number 2, pure IP. This is practice number 3, mixed IP. This is practice number 4, 01 IP. Oh, you have 4 persons, so can you do? Choose one. Who will choose this? You want me to assign for you? Okay, so I will assign. This one. Okay, this one is Dave. Put name. Okay. And then this one.
Wait, mine is the LP or the IP?
The practice IP and LP relaxation.
Oh, both.
Yes. The same problem anyway. Okay, and then the second one. Where is my, why my slide is freeze? So this one is the second one, practice pure IP, Tiara. And then next one, Kalista, and the last one, Celine. Okay.
Excuse me, sir. Can you show me the question, sir?
The question is in the slide. Can you open the slide?
Okay.
So page 20, Dave. Dave. Pure IP, Tiara. Mixed IP, Kalista. Practice 01 IP, Celine. You get the problem? Oh, easy. You just use Excel. You. So this one, Celine. This one, Kalista. Can you see? This one, Tiara. And this one, Dave. Okay. Look at your assignment. Okay, good. So I will stop sharing. Your turn to share. You can share your screen. I will help you. Okay.
Yes.
Okay, so x1 is 2x1 plus 3x2 subject to constraint. Okay, so x1 plus 3x2 less than 8.25 x. Okay, so so you have this problem here. So you just put there in B10 and B and C10, yellow and yellow. No, in home. There, you put yellow, and then that one also yellow. Okay. There. So you put any number, 00, it's okay. Okay, and then keep name. So you know how to keep name, right?
This one, yeah.
Yeah, X_1. Okay, and then that one X_2. Okay, very good. So now you can calculate the Z in, for example, E9, you type Z, E9, you type Z, and then E10, enter.
E10.
E10 is equal to 2 multiplied by, multiplied by
Oh, yeah. 2 times
multiplied by x1, right? And then
plus
plus what 3 multiplied by x2. Okay. Did you put name a while ago? Why did not enter? Anyway,
it's
enter.
my enter is broken.
Okay. You just go there and then put. How do you put and you can use a virtual keyboard if you want.
Ready.
Okay, so you can just change to test this true or not. So you put 1 and 1 in x1 and x2 so that you will see if it's what. Okay, good. So that's the objective function. So now you go to the constraint. So you type there in 12, B12 constraint.
Equal constraint.
No, just this type constraint. Okay, so constraint number 1. So there. X1 is no equal, yeah, that one, but you need to put down there, right? Equal, let me
Equal
check.
to
Yeah,
this
that one plus
plus
3 times
B10.
x2. Enter.
Then
Okay. And then the second one is what? 2.5 multiplied by x1 multiplied by multiply, not divide. Yeah. And then plus x2. Okay, enter. Okay, so now you go to solver. Let me see if you have solver in your data.
yes, I do.
Okay, you have data. Okay, then go to solver. Okay, and then set the objective is Z, that is E10. No, E10 only, without B2. Okay, and you want to maximize that, correct? By changing cell, the yellow part. Okay, and then subject to constraint, add.
This one.
Yeah, you add first. You add one constraint there, add. Okay, the left hand side is the one that put there. B13, right? B13 less than
or equal.
8.25.
Oh,
And then add the second one now. Yes, B14 less than 8.75. Add again your cell X1, X2, B10 and C10.
oh,
Both of them. That one must be integer. Integer. No need the yeah, integer. Oh, okay, now click OK. Okay,
Yeah.
so you already put there, you see the checkbox there, make unconstrained variable non-negative. Right? That is the same as x1, x2 larger than equal to 0. So you don't need to add in that constraint. And then you just say solve. Oh, there, and then click OK. There. So you get the solution, 2 and 2. Okay. So now let's try. The solution is 2 and 2, yeah? Let's try for LP relaxation. So what you will do, you go to the solver a while ago, click again, the solver. And then you remove that the first constraint integer. Delete. And then solve.
Oh.
Oh, you did not
Also,
solve. There. Is it close? So if you see this,
yes.
okay, 2 point something, 1.7, and then 1.8. Okay, so it's close to the actual one. But the IP will give you 2,2. Okay, but if you go up, it will give you 3,2. Which is not the solution. If you go down, it will give you 2,1, which is also not the solution. So LP relaxation, okay, just give you the exact value of the constraint, but IP will give you the integer value. Clear? Good. So, Celine, thank you, Dave.
Yes.
Show your work.
Not yet, loh, sir.
Kalista,
Three of us not yet done, sir.
okay. Oh, uh, okay, one of you show so that I can help.
Yeah, maybe I will share my screen, yeah, sir.
Okay. What make it difficult?
Actually, a little bit confused.
With?
For the first one, is it the same with Dave? How
Yeah.
to solve
So
it?
all you need to do is to put the name of variables. Okay, so x1, x2, you put yellow so that you know this is the variable that you want to search.
Yeah.
Okay, and then give name. You know how to give name, right? You can select G and H, 9 and 10. Select all of that. G, 9 and 10. And then go to formula.
Here.
Yes. Create from selection. There in the middle. In the middle, there's create define names, create from
Oh,
selection. Okay. Above. So that means top row. Okay. Click up. Oh, maybe it doesn't work. Click from. You need to ano, from 8, I think you need to go 8 and 9. Highlight and both of them, yes, and then select
oh,
create from selection again. Formula create from selection top row. Click OK. Yeah. So you can go to G9. G9. Oh, there it's already give you the name of variable. Okay.
yes.
Okay, so now you have the variable, you define the variable. Next, you define the objective, right? So which one is yours? Celine is 01 IP, is that correct?
Yeah.
Okay, so define Z. Where is the Z? That
This
one
one.
is x1 minus x2. So you just equal,
It's done, sir.
it's done. Okay.
G9 minus H9.
Okay. And then subject to constraints. So the first constraint, can you make? So x1
X1.
plus 2 multiplied by x2. Yeah, enter. And then second one, 2 multiplied by x1. minus x2. There, enter. Okay, so finish. You already have that. So go to your data tab in the menu. Menu, data. There. Oh, you have solver already. Good.
Yes.
So objective is to maximize your z. Z is J. What is that? Okay, J9. And then changing variable cell. What do you want to say? That two yellow. Okay, and then the first constraint in the left hand side, G12 in your case.
This
G12.
one.
Yes, that one must be less than 2. And then the second constraint, the second one, less than 1.
Less than 1.
And then and then the two constraint, the two variables, x1, x2, you highlight G9 and H9, the two of them.
This.
Yes, the yellow one.
Oh,
That
berarti
one
kalau
must
kita
be
ngomongin
0 and 1, binary, bin, bin. Okay, and no, okay, click OK. Then let's solve. Solve. There, you solve a problem. Click OK. There, the result. The result is the result.
macam-macam.
Okay.
Jadi kalau
Okay.
gitu,
You can try
Okay.
again. So what you can set 1, 1, and then it will give you the same answer anyway.
Okay. Thank you, sir.
Okay, Kalista, Tiara, make sure you can do this first before we go next. Come on.
Oh, I will share my screen, sir.
Yes. Please. Oh, you solved it already. Can I see the solver?
Oh, yeah.
Okay, so maximize B, C, subject to constraint. Yours is pure IP. Is that pure IP
Pure.
or pure IP? Okay.
Yeah.
Okay, pure IP is just one constraint, right? And then integer. Okay, the two of them. Okay, so you get 6 and 0. Very good. Okay,
Oh, is that already correct, sir?
I think so. But you can check the make unconstrained for non-negative.
Oh, this
Why
one.
did you not check that? Yes.
Okay.
Anyway,
yeah.
we got the same result. Good.
Thank you, sir.
And Kalista, thank you. I just want to make sure you're okay. So integer programming easy? Eh?
Sir.
Hey, what is this?
So,
Okay,
ignore
what is your Z? Your Z is where is located in
here, suppose.
where is your okay. Okay, you did not make it yet, so make it. What is that iteration 0?
Ignore this one.
Okay, ignore that one. Your Z. Okay, so you are mixed IP, right? Is that correct? Okay, so
Yes.
did you put name so that you will get a better result? Or you did not? Okay, no, you highlight everything from C11 to D12. Put up no from including the variable name. Up a little bit up. C11 to D12. You highlight C11 to D12. Okay, and then you go to formula. Formulas.
Wait.
Formulas.
Wait.
Okay, and then in formulas, you see create from selection. Define names. Okay, create from selection. No, create from selection. Okay, top row, correct. Click OK. Okay, now you go to C12, you can see. Go to click C12. Ah, see your name, your variable name is there. Okay, now go to Z, F12. Okay, so which is equal 3 multiplied by your x1, okay, plus 2 multiplied by, no need,
put
it's a
brackets.
2 multiplied by that one. Okay, close. Okay, good. Now you have it. Now the first constraint, subject to constraint, to go in that one ST. Oh, you can just put, yeah, okay. The first one is, oh, you have only one constraint anyway, so x1 plus
Yes.
x2. So in that case, very easy. X1 plus x2 equal x1 plus x2. Enter. Okay, now go to solver, data. Go to your data tab, data menu, in the menu data, solver.
solver.
Yes. You need to maximize, so your Z, you put Z is F12, right? Go to objective function, no. Objective function. Set the objective function to be the Z value.
Okay.
Okay, you want to maximize, correct? Changing cell is the yellow one, the 2 yellow. Delete first so that you can, okay. Subject to constraint, you add.
Oh, okay.
Okay. The left hand side, it is C16. C16. Okay. Less than equal to 6, right? You type 6 on the constraint. 6. Add. And then x1, x2. Oh, no. Only x1, sorry. x1 only. In your case, mixed integer. So x1 only becoming integer. No. X1 is C12 integer, correct. Click OK. And then solve.
This
Oh.
one?
Solve. No. Just, that's correct. The GRC linear, non-linear is fine. Solve.
Okay. Okay, wait.
Right? Just click solve. Oh, then you get the solution with the 6 and 0. Hi. Okay, that one you remove. Clear content. No, clear content. Okay. So, integer programming, is it difficult or easy? Easy, right? All you need to do, huh? Laughing. Why? Before you need to make the iteration? Huh? You compute using iteration, using linear algebra when you do in OR1 LP. Is that so? No, in OR2 you don't need that. Okay, just directly solve it. Is that okay or not? Okay, so now I want to make your life more difficult. Okay, now let's go to the real problematic IP. So, can you see my slide? Okay, so what kind of problem using IP? Okay, any problem that involve integer, okay, you can use IP. So we will discuss knapsack, okay, and we will discuss binary tree. Okay, we will discuss binary tree first. TSP probably I will discuss. Short cover, I'm not sure. Okay, binary tree first. So when you have a decision variable, for example here, okay, so whether you will build the factory in Los Angeles, yes or no, then put this as X1. Whether you will build factory in San Francisco, yes or no, you put as X2. Yeah? Whether you will build a warehouse in Los Angeles, yes or no, so you put X3 and so on. So any variables that involve decision, okay, for to be yes or no, then you can create integer programming. Yeah. So then you just set this variable to be binary. So up to here, is that clear or not? So next, okay. Next is called so you can read this in my tutorial. Okay, so say you have many discrete values. Okay? If your variable involve discrete values, so there are two methods. Okay, one is to assign each discrete value of the category as one binary variable. So this is 1 to 1. The second method, okay, is to assign each of discrete value of the category into several binary variables. Okay, that means 1 to many. So I'll give you example. Okay, this is easy. Yeah, method 1 is to assign each discrete value of the category into a binary variable. Yeah. So for example, you have a list of discrete value like this, right? So then each of these variable you put as 0 and 1. Okay. Here example again. So I have 3 data. Okay. Alex, Brian, and Cherry. Okay. This one I have gender and mode is to use what transportation mode. So for each variable, okay, I will have assignment, right? 1 to 1. So gender is 0 and 1. The mode, yeah, I have 3 possible mode. So each discrete category you put as 0 and 1. Can you see this? So bus is either 0 or 1, train is 0 and 1, fun is 0 and 1. So in that case, if you say gender and mode, that will become how many variables? 4 variables. Okay. So gender is this one, 0 and 1. Okay. Alex is female, male is 0. Okay. And female is 1. Cherry is 1. Yeah. And then the mode, you need to set. Yeah. So this one, the first one is for the bus, second one for the train, the third one is for the fun. Is it clear or not? When you assign 1 to 1, okay, so you list all possible discrete value, and then for each discrete value is either 0 or 1. Okay. The good thing of this technique is very simple to interpret. Okay. But, okay, if you have a lot of discrete values, this is very bad because the number of variables become very big. Okay. So the next method is to assign to several binary variables. So the technique is a little bit more complex, okay, but you will have less number of variables. So the technique is to get how many variables that you need to satisfy the condition. So the number of variables, okay, depends on the number of discrete values, C, and then you divide by 2, and then you take the ceiling. Okay, ceiling means round up. Okay, so the assignment of the binary variable is somewhat arbitrary as long as it's consistent. Okay, so I'll give you examples so that you will know. Say you have the 3 public variable a while ago, bus, train, and fun. So you have 3, right? three values. So 3 divided by 2, log 3 divided by log 2, and then you take the discrete value, you will get log of 1.58. Yeah, which is the scaling of this is 2. So you only need 2 variables. You see, instead of 3 variables, now you have only 2 variables. So then you assign. Okay, you said bus is 1, 1, train is 1, 0, fun is 0, 1. Is it clear or not? So in that case, okay, when you have 2 variables, yeah, gender and mode, okay, then you will have this is the way to set the dummy variables of binary. Is this clear? So I give you another practice so that you will see. So suppose you have a discrete, you know, the bridge card have 52, right? So a lot of discrete value. If you use one-to-one method, how many binary variable you will use? Okay, you will have 52. Okay, so in this case, you need the AZ, yeah, capital letter and small letter. Okay, so, but if you use one-to-many, how many variable that you will use? That one you can compute, yeah. So you only need 52, yeah. So in this case, you will have only 6 variables. Okay, you only need 6 variables. For 52, you only need 6 variables. So, but you need to assign, yeah. So A is 0, 0, 0, 0, B is 0, 0, 0, 1, C is like that, yeah. D is 1, 1, and so on. So you create a binary system to represent that A to Z, A to C. Is this clear or not? Okay, so this is a trick, okay, to create a binary variables if you have many values. If you want to represent values, you can also trick, okay, if you want to create logic, yeah, in your constraint, okay, you want to create logic, then you can also use binary variable, yeah. So these are the table that you can use. For example, if A then B, that is the same as this one. Yeah. If not A then B, this is the same as this one. If A then not B, though, this is the same. So you can use this later on as your table of reference. So I give you example or. Okay. So suppose you have 2 binary variable, x1 is project 1, x2 is project 2. Then you have constraint of x1 plus x2 larger than 1. That means what? That means or, yeah. So at least one of the variable must be selected, right? So if you want to use logic or, yeah, this is the constraint. Yeah. Plus and then must be larger than 1. That is the same as or. If this is binary, you will get exactly the same. Is that clear? So if you want to use a non-variable constraint, okay, suppose then you will have less than 1. Yeah? Okay, so you see the value is exactly the same. Yeah? So this means at most one of the variable must be selected. Yeah? You can also use SOR. Okay, that means at least one of the 2 constraints must be satisfied. So you can use large number m to create this constraint. So anyway, if you want to do if you want to go more detail, okay, read the reference book, yeah, with Zillier and Lieberman. So there are a lot of example in that book about all this detail on integer programming. Yeah? So I'll give you example here. Say you want to do SOR, okay? That means either this one less than 18, so you can put this. Yeah. So at least one of these 2 inequality must be whole, but not necessarily both. Wow. If you have this kind of constraint, it's complicated, isn't it? If you use LP, cannot be done, right? Yeah, because you have a constraint that is not both, yeah, but must be solved. Only this or that. Yeah, if you have this type of constraint, you can do using integer programming, yeah, but you cannot use linear programming. Okay. The technique is to add m. Yeah. Okay. So there are a lot of so for example, this one is if then, yeah. If variable 1, then variable 2. So if project 1 is selected, then project 4 is also selected. So you can create the linkages between constraint. Okay. So this is the meaning. Yeah. So x4 larger than x1, that equivalent to x4 minus x1 larger than 0. So this is actually meaning x1 is selected, then x4 is also selected. So there is a logic in binary that you can use in integer programming. Okay. This is something that you cannot do in other method of linear programming. Okay, so I think this is the time. You said we want to stop early. So next up, I will discuss the next meeting. So is there any, before we leave, so is there any feedback, question, probably? What did you learn? Do you realize that using integer programming, you can put constraint which is logical? Using and, or, SOR, if then. Okay. So it's very useful, right? So using LP, you cannot do that, but using IP, using integer programming, you can do a lot of things that the LP cannot do. Okay. Simply because you have a logic of binary. Okay. Okay, then. So I think today is until here. Thank you very much for today, and you can go to the next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.